Good day to all of our viewers, not only here in the Philippines, but also in other countries who are watching on my videos. If you are new here, don't forget to subscribe. Just click the subscribe button there so that you will be notified of my new videos, of my new tutorial videos that will be uploaded here in YouTube. Alright, so last time we actually talked about the differentiation of the algebraic functions. This time it's kind of interesting because we will be discussing the logarithmic and exponential functions. So the next video that I will be doing, or I will be uploading, is the trigonometric functions, the inverse trigonometric functions, the hyperbolic functions, and the inverse hyperbolic functions. So if you guys are interested, so just click the notification button there so that you will be notified if I upload all of these videos. Alright, so let's start. So the formulas, or differentiating the logarithmic and the exponential functions, you really have to understand all of these 5 formulas that I will be showing you. That one, this one, that one, that one, and that one. Alright, so I'll be giving you examples for that later on. So those are the formulas you really have to remember. Alright, so these formulas are really important in terms of the logarithmic and the exponential functions. Alright, but you also have to remember and to always bring your knowledge of our previous tutorial, which is in the algebraic expressions, because sometimes our teacher just combines all of those. There is a logarithmic and then you multiplied it to another, so that becomes a product rule and all of this. So but this time we'll just be focusing on the logarithmic and exponential functions. Alright, so that is why you really have to bring your knowledge in all aspects that you are solving. So let's start now with our first formula. So our first formula is differentiating log base a of u is actually equals to log base e of e du over dx over u. So you know what, guys, the a there is a constant. All right, so if you see a logarithmic functions that you will be differentiating a logarithmic function with that a there that is constant, and that u there with a variable x, it can be an expression or a term that has x. Right, so this is how you're gonna solve that. You're just gonna put log base a of e, then du over dx over u. All right, or there's an or, because you can also write that as du over dx over u ln of a. You know what, if you're gonna solve using the first result, which is the log base a of e d over dx over u, that will give you the same answer with du over dx over u ln of a. Alright, so either of the two, you can use either of the two whenever you encounter problems such as log base a of u. Alright, where a there is constant again, and u is an expression or a term that consists of that has a value of the variable that you are differentiating. Alright, so now let's give you an example. So we say you have y is equals to log base 10 of 3x plus 2. So how are you going to solve that? So simply you just have to substitute to the formulas what is given in the formula. So say that log there is actually this one, and that u there is 3x plus 2. Alright, take note for that u is actually 3x plus 2. So if u is 3x plus 2, we can say that our d over dx is actually equals to 3. If we differentiate the 3x plus 2, that is 3. So that is du over dx. We differentiate the value of our u. Alright, so now if that is the d over dx, then we can say that du over dx all over u is actually equals to 3 over 3x plus 2. Okay, so 3 on the top as the numerator and all over the value over u, which is 3x plus 2. So we have to know first these things before we substitute to the formula. And since we already have that, then we can say that for our solution that dy over dx, the differentiation of the function, which is log base 10 of 3x plus 2, is actually 3 over 3x plus 2 log base 10 of e. Alright, so that is how you're gonna solve that. Alright, so that is actually equals to 1.3029 over 3x plus 2. So that is now our answer, because you can no longer, put it in the lowest term. So that is our simplified answer. So that is our simplified answer. Alright, so that is just how you're gonna do that. So you just need to know first everything that is in the formula, so that later on you just have to substitute for it. So I advise here you solve a lot of logarithmic functions so that at least you can familiarize it already. Alright, so that is our first formula. So now on our second formula, we have log. Here, the e, or the Neperian logarithm, becomes our base. Alright, so log base e of u is actually equals to du over dx over u. Right, you always remember that. In this case, the e, or the Neperian logarithm, becomes our base. Alright, so that is just du over dx over u. And also log e, take note of this. Log base of e is actually an ln, or the natural logarithm. Alright, so if that is a natural logarithm, we can say if you encounter problems differentiating the ln of u, then that is also equals to d over dx over u. Alright, so if you encounter log with the base of e, that is d over dx over u. So if you also encounter ln of u, that is also d over dx over u. Alright, so let's give you an example. So say we have y is equals to ln quantity x squared plus 1. How are we going to solve that? So first, in our solution, as I have said, you need to identify first what is given in the formula. So our u there is actually x squared plus 2, alright? And our du, differentiating that, we'll have 2x, alright? So if d over dx is equals to 2x, then we just have to substitute it in our formula, which is d over dx all over u, so that we will have 2x over x squared plus 1, alright? So that is now our answer. So that's kind of, so here you just, the formula is already given. It is just that you must know how to use the formula. Alright. So now in our third formula, we have differentiating a raised to the power of u. Okay, this is actually an exponential function here, where a is constant and the u is a term or an expression that composed of a variable that you are differentiating. Say we have x, so the value of x is on the exponent, right? So how are you going to solve that? And the base is a constant. So the formula, based on the formula, differentiating that, we will have log base e of a multiplied to a to the power of u multiplied by du over dx. So that is how we're going to solve if your exponent has the variable that you are differentiating. Alright, and take note that a there is constant. Alright, and also if you see on the formula, there's a log base e there, and that log base e there is actually an ln. Alright, so we can say that this formula can also be written as this one. Alright, So if it depends on you who you will be doing the computation, all right? So it's up to you which of this you're gonna use, but they have the same answer, all right? So because lag base e is just a natural logarithm, so we can rewrite this as this one. So say we have an example that is y is equals to 4 raised to the power of 2x plus 3. So our base there is constant, and that is 4, and our u there is 2x minus 3, and differentiating u we will have d over dx, and that is equals to 2. So now we are ready to substitute that to our formula, and we will have ln of 4, so that is just this one, and the a is 4, so that will be multiplied to a raised to the power of u, that is 2x minus 3, and then our d over dx is just a 2, alright? So that is just how you do that. And then differentiate, after that you already have that, you just have to simplify it, and simplifying this we will get 2.7726, that is being multiplied by 4 raised to the power of 2x minus 3. So now we already have our answer, so that is our answer, because we can no longer simplify that. So that's the answer, alright? So you know, in the differentiating equation, you just have to know the formulas, and then you must know how to use these formulas. And also, before you substitute that to the formulas, you get all the necessary variable there. So like a, like u, and d over dx, you must know all of them first, so that later on you just have to substitute them. Alright, so that is if you encounter a problem, an exponential problem with an exponent that has an x, or a variable that you are differentiating, and a is constant. Alright, so in our first formula we have differentiating e to the power of u. E is an Aperian logarithm, alright? So e to the power of u, we will just have e to the power of u d over dx, and this is my favorite formula because this is kind of the easiest formula in the logarithmic and exponential functions, right? You're just gonna copy the original equation, which is e to the power of u, and then you multiplied it to d over dx, or the differentiation of the value of u, or your exponent, alright? So say you have y is equals to e to the power of 2x minus 3, alright? So the exponent has the value of the variable that you are differentiating, and your base there is e. So all that you have to do is you have to know first the u and the d over dx, and of course it's very obvious that your u, or your exponent, is 2x plus 3, and differentiating that we have 2, alright? So our solution there is you could just copy the equation, the original equation, which is e to the power of 2x minus 3, alright? And then you multiplied it by d over dx, and that is 2, right? So that is very easy. So you have that, you just rewrite this because that's the simplified equation for that. So that is now our answer, alright? So this is the easiest formula here in the logarithmic function and the exponential functions. Alright, so that is our fourth formula. So our next formula and our last formula, alright, for the logarithmic function and exponential function is this one. And this formula is actually, a lot of people are looking for this. So for our formula is u to the power of v. Why I say a lot of people are looking for this? Because a lot of people have encountered that their base has a variable that they are differentiating, and their exponent has 2. So if your base, say you are differentiating in terms of x, and your base has a value of x, and also your exponent has an x, so this is a perfect formula for you. Alright, so you have v multiplied by u, and your to the raised to the power of v minus 1, then d over dx plus u to the power of v ln of u dv over dx. So that is just, and again you just have to know first all of this, the u, the v, the d over dx, and the dv over dx, so that later on you will just be substituting all these values. So say for example you have x raised to the power of 2x minus 2. So your base is a value of x. Of course, it is x there. And then the exponent also has an x because it is 7x minus 2. So there's an x there. So this is how you can do that. So the x there is our u, and our v there is our 7x minus 2. So that we can say that d over dx is 1. Alright, because that is just an x, so if we differentiate that, that is 1. And dv over dx, that is 7. Alright, 7x minus 2, differentiating that, we have 7. So now we are ready to substitute that. So in our solution, we just substitute that our formula. So we have vx minus 2 multiplied by x raised to the power of 2x minus 3. That becomes minus 3 because v minus 1. So you have 7x minus 2 minus 1, and that becomes 7x minus 3. Plus x raised to the power of 7x minus 2. You just follow the formula there, ln of x, and then multiplied by 7. Alright? So simplifying that, you have x raised to the power of 7x minus 3 plus 7x minus 2 over x, 7 ln of x. Alright, so that is just how you simplify the formula, and then that is now our answer. Alright, so that is just how easy it is. You just have to, you just have to do that. So I hope you learned something today, and I hope you really learn a lot today about logarithmic and how to differentiate the logarithmic and exponential functions. So if you guys are interested with all my videos, just click the subscribe button, and so that you will be updated over new videos. Thank you so much for watching, and have a good day.
Subscribe.
Subscribe! 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 Subscribe!
Subscribe.
Please like and share. Subscribe.